What if the strangest objects in the universe aren't science fiction at all, but already out there right now? Some galaxies hide supermassive black holes at their cores, millions of times heavier than the Sun.
Gas falling into a supermassive black hole forms a hot spinning disk, and the event horizon is the boundary where even light cannot escape.
At the center of the Milky Way, a supermassive black hole about 4 million times the Sun's mass hides among the surrounding stars. A neutron star is the collapsed core of a massive star, heavier than the Sun, but only about the size of a city. Some neutron stars become pulsars, spinning fast and sweeping space with narrow radiation beams. A teaspoon of neutron star material would weigh hundreds of millions of tons on Earth. A magnetar is an ultra-magnetized neutron star with the strongest magnetic fields we know of anywhere in the universe. A magnetar's magnetic field is so extreme it can warp metal and even tear apart normal atoms. Sometimes magnetars unleash brief bursts of X-rays and gamma rays with incredible power. Quasars are tiny galactic cores that shine brighter than all the stars in their host galaxies.
Each quasar is powered by a supermassive black hole, feeding on gas and often launching twin plasma jets.
Most quasars we see are billions of light years away, so observing them is like looking at a much younger universe.
Super Puffy planets are Jupiter-sized gas worlds but far less dense, almost like inflated giants.
Some of these planets are so light that their density is closer to foam than rock, far puffier than Jupiter.
Super Puffy planets often orbit very close to their stars, where intense heat swells and erodes their outer atmospheres.
Some distant exoplanets are so rich in carbon that their interiors may hold huge layers of diamond. Models suggest a rocky outer shell, a graphite layer beneath, and deep inside, a vast diamond zone. Diamond planets would be unlike any world we know, shaped by exotic carbon chemistry instead of water and rock. Cosmic voids are huge regions of space, hundreds of millions of light years across, with almost no galaxies at all. Inside a deep void, galaxies are so far apart that a single one would sit in almost complete darkness in every direction. Seen from far away, voids and the filaments around them give the universe a sponge-like, web-shaped structure. Dark matter is invisible, but around many galaxies it forms a vast halo that helps hold their fast-orbiting stars in place. In many galaxies, the stars and gas we see are just a small part of the mass. Most of it is invisible dark matter.
Dark matter's gravity can even bend light, acting like a lens that stretches and distorts background galaxies.
The cosmic microwave background is the faint afterglow of the Big Bang, from when the universe was very young. These tiny temperature differences are fingerprints of the first clumps of matter that became galaxies. Scientists call the cosmic microwave background the baby picture of our universe.
When a sun-like star swells into a red giant, its outer layers can expand enough to engulf once safe orbiting planets.
As a planet skims a red giant's atmosphere, its surface vaporizes, losing mass and slowly spiraling deeper into the star.
Astronomers spot these events in tiny changes in a star's light and chemistry, and in planets that simply vanish from their orbits.
These 10 were just the beginning. If the universe can do this, what else is hiding in the dark?